All right, this is Module 6, Lesson 2. We'll also call that just the Introduction to Slope-Intercept Form. All right, where we start with this lesson is a new term called the y-intercept. The y-intercept is just the y-coordinate of the point where the graph crosses the y-axis, or the value of y when x is equal to 0. That's a little bit weird, so let's just take a couple examples and sneak up on the idea, all right? So down here, we're given 3 lines, and we're asked to find the y-intercept, or y-int, of each one. Let's see where to start. It asks us for b, so let's look at b. We see, where does b cross the y-axis? Well, it's right here, right? This is the point where the line b, which is this line right here, intercepts or crosses the y-axis, is at 2. So to fully use our definition, when x is equal to 0, right, that's our x-coordinate, y is equal to 2. That's the y-intercept of the line B. What about A? When the x-coordinate is equal to 0, what is the y-coordinate? Well, we've gone over 0 and up 0. It crosses the line at the origin, 0, 0. That one's pretty easy. What about line C? When x is 0, so when we've gone left or right 0 times, right? 0 times this direction or 0 times that direction, what is the y-coordinate? Well, it's -2. So for line C, when the x-coordinate is 0, the y-coordinate is -2. All right, so now we found the y-intercept of each of those lines. Pretty straightforward. Now that we have that, now that we know what the y-intercept is, we actually can start thinking about how do we write equations that tell us, that describe one of these lines, right? If I have line C here and I ask you to write me an equation that I would be able to use to represent or stand in for that line, how do you do it? And well, it's actually not that hard. All of those lines, any straight line, so any linear function, can be represented in a form y equals mx plus b, where m, as we already know, is the slope. Oops, that's not how you spell slope. That's slope. And the only thing new is that the b, right, the b is the y-intercept. Okay? So once we have that, we can actually just use the pieces of information we already have to plug it in and write the equation of the line. So let's, for instance, look at line B on this original example. Well, we start out just with y equals m. We need the slope, and the slope for all of these lines, right, rise over run is just 2 over 1, or 2, so the slope is 2. Write our x, and then plus b. Well, what's the y-intercept? The y-intercept of line B is just 2. So y equals 2x plus 2 is the equation that represents that line, right? If I gave you this equation right here and told you to graph it, you'd be able to, right? You would draw a point at the y-intercept, and then you would just you'd go up 2 over 2, up 2 over 2, and you'd get a couple different points, and then you could just draw the line and you'd be done. All right, so the next and somewhat, a little bit different idea here is that because we know the equation of a line is y equals mx plus b, we can use that to find an equation even when we don't have the y-intercept. So I'll show you what I mean. Find the slope-intercept form of a line with the slope of -1 that passes through the point 2, 4. So that's all the information you need, right? If you knew that a line has a y-intercept of -1, so let's say it crosses right here, and that has a slope of -1, well, you could draw that line, right? You could graph it, you'd draw the line, and you'd go down 1 over 1, down 1 over 1, down 1 over 1, get a couple points, and draw the line. You'd be good to go. But what if you don't have a graph, or maybe the numbers are weird, and how do we figure this out? Well, we just substitute in what we have. Start at the beginning. Do we know a y value? Well, yes, we do, right? Y over here on our point is equal to 4. So y equals 4. Do we know an m value? Well, yes, we do. M is the slope, which is -1. Do we have an x value? We still do, right? We know that x is equal to 2. Do we have a b value? Well, no, not yet. We don't, right? So type in, just write down a b. From here, this is just a two-step equation. You guys know how to solve these. It's not barely even a two-step equation, right? We combine like terms. So we leave our 4 here. -1 times 2 is just going to get us a -2 plus b. Now we just need to isolate the variable, right? We're trying to get b all by itself. And the best way to do that is to add 2 to both sides. We add 2 to both sides. We're left with a 6 on the left and a b on the right. Well, just like that, now we know what the y-intercept is, right? We know that we have a slope of -1 and we have a y-intercept of 6. All we need, that's all we need to graph, right? We'd count 1, 2, 3, 4, 5, 6 up, draw a point, and then just go down 1 over 1. Oops, that's not what I was trying to do. Down 1 over 1, draw a point, down 1 over 1, draw a point, down 1 over 1, draw another point, and then just connect those dots, and we'd have a line, right? So now just to formalize the whole thing, we now know a slope and we know a y-intercept. So y is equal to the slope, -1x plus 6. And this equation right here describes this line right here and is built from this information up here, the slope and 1 point. All right, that's all I got.